Good morning, everyone. Welcome to VSP Educational Society Educational Channel. Today, we are going to discuss a topic, law of conservation of energy for an object which is falling freely under the gravity. To understand this concept, I have considered a body of mass m falling freely under gravity from height h. So this is position A. After traveling a distance x, this position B, and at ground position C. So at position A, initially at position A, just let me just clear all drawings. At position A, let me just take pen. Wait a minute. Yes. At position A, initial velocity of body is equal to 0. So if velocity is 0, so the kinetic energy will also be equal to 0. And potential energy due to the height at position A, potential energy it's going to be mgh. Okay. Hence, total energy at position A, it will be equal to the sum of kinetic energy and potential energy. And the total energy is coming mgh. Same at position B. At position B, here, when it traveled distance x at position B, here it is. So at position B, let v1 be the velocity acquired by the body after falling through distance x. So initial velocity, because it is falling from the state of rest, so the initial velocity will be 0, and distance traveled, or you can say distance acquired by the body, is x, which is given. A is equal to g, which is the gravity acceleration due to gravity. From the third equation of motion, v square is equal to u square plus 2a s. We can find out the velocity. Okay, so the kinetic energy going to be k is equal to half mv1 square mg x. Now at B, we are discussing at position B. So height of the body above the ground going to be what? Let me just show you. Wait. You just look at this figure. Let me just clear all drawings. Yes, here it is. At position B, height from the ground, total height was what? H. This was the total height. And when it is falling freely under the gravity, it has traveled distance x. So the distance from the ground going to be what? H minus x. Okay. So now you can see here at position B, here position, yes, here it is. At position, yes, at position B, the potential energy going to be what? Mg into height, which is h minus x. Hence, total energy is equal to what? Sum of kinetic energy plus potential energy, mgx plus mg, product of h minus x, and it's going to be again mgh. So what we are getting, that energy at position A also mgh, and at position B also mgs. Let's check out at position C. So at position C, v with the velocity, we are just assuming v with the velocity acquired by the body on reaching the ground. So similarly, from the third equation of motion, we can also find out the velocity, which is going to be what? V square is equal to 2gh. Thus the kinetic energy from this formula, kinetic energy going to be what? Mgh. Now at C, height of the body from the ground going to be what? Tell me very quick. It's going to be h. Thus the potential energy is 0, because the height from the ground is 0. Now hence total energy, which is going to be sum of kinetic energy and potential energy, and it is again going to be equal to mgh. Okay, so what we are getting, thus the total energy, or you can also say mechanical energy always remain constant, which is equal to what? Mg at every point, at point A, B, and C. Hence, we can say mechanical energy is conserved. So based on this concept, I hope that this concept is clear to all. Okay, so now based on this concept, let me just clear all drawings. Yes. Yes. Here is a numerical problem. So you all will try this numerical problem. So let me just give you the hint for this question. You will have to use this same concept of law of conservation of energy. In this question, we will have to find out the height from which a toy is dropped if it goes in free fall state. Okay, the final velocity achieved by toy is 20 meter per second. So how you will solve this? The energy is transformed from one state to another. Okay, so at higher position, the energy will be in the form of at height. At height, energy will be in the form of potential energy. I'm just representing it by U. Okay, when it starts falling from that height, so that energy going to be transformed into kinetic energy. Okay, so the concept we have just discussed, that energy is conserved. Okay, so kinetic energy will be equal to what? The total energy will be same at each point. So at that point, when the final velocity is achieved, kinetic energy going to be what? Total, which is total energy at that point, half mv square. It's going to be equal to the potential energy, which is also total energy at that point, which is at height h. I'm just assuming that height is h, so you can find out the value of h. Okay, so I hope that this concept is clear to all. So you just write the answer of this question in the comment section. Still, if you have any doubt, you can write your doubts in the comment section. I will take your doubt. Thank you, everyone. Thanks for watching the video also.